Okay, so we're nearly finished. Unit 2, lesson 3, energy and how collisions show energy, which means I'm not going to be able to use um, my Angry Birds picture for much longer. So what we're going to be doing today is we're going to be going a little bit deeper into collisions. By that, I mean you're going to be making connections between things like cause and effect to do with collisions. We did those before the break. I don't think we did them yesterday. And we're going to be comparing and contrasting two different scenarios, or a couple of different scenarios. You're going to analyze them, and then you're going to make your conclusions about collisions, but all will be revealed in good time. And yeah, this whole thing then is to consolidate what we've been learning about. So, vocab. Yes, we're doing this again because the vocab is very important. So I want to ask, Sophia, can you remember what's a collision?
Collisions mean an impact or crash.
Oh, good girl. Yes, exactly. An impact or crash. Thank you, Sophia. Next up, we've got the verb to collide. And Lisa's going to tell us what that means because you've got your hand up.
To collide means to hit, impact, or crash into.
Perfect. Okay, yep. To hit, impact, crash into. Very, very good. Thank you, Lisa. Potential. This one's a little bit tricky. Well, Aisha, your hand is up.
This means that's what it could become.
Good job. It's what it could become, or what it could be. Thank you very much, Aisha. Quindana, you back? Nope, lost her. Potential energy. So if potential is what it could become, potential energy means Vegetal Blue. What is potential energy?
Energy that I don't remember it.
Energy that could become
Motion energy.
Good man, yes. So stored energy or energy that could become motion energy. Maradona, can you think of an example of something that has potential energy or stored energy?
Battery.
A battery, good, that's got chemical energy. But what about something that doesn't have chemical energy? What about something that we either stretch or compress?
Food.
Food, again, that's chemical energy. Do you compress your food? I hope you don't compress your food.
No.
Stretch your food. What do you use to ping across the classroom?
Rubber band.
Something stretchy. Rubber band, good job. So a rubber band is a good example of stored energy that can become motion energy, because obviously when we let go, it goes flying across the classroom. And I get a bit cross. Energy transfer. Now, what is an energy transfer? Courage?
Energy transfer is.
Can you remember if it's when energy moves or changes?
Move.
Moves, good job. So it's when energy moves from place to place or from object to object.
Object to object.
Good job. And I wonder if Neymar, can you think of an example of an energy transfer? Any example where energy is transferred from one object or place to another object or place?
The dominoes.
The dominoes, very good. Yeah, so when we made our little Rube Goldberg machines, what did we do, Neymar? How did we start it off?
We push the domino.
Good job. We pushed the dominoes, and then what happened? That motion energy from, yeah?
Transfer.
Yeah, it transferred what kind of energy?
Motion energy.
Good man, perfect. All right, thank you, Neymar. And then lastly, we've got energy transformation. So if energy transfer is when energy moves from place to place, I wonder if Myth, can you tell us what energy transformation is? So if transfer is when it moves, transformation is when energy does what? Think about Transformers, the movie, or werewolves. When they turn into something else, what's that called? Chicha?
Energy type is change like from motion to sound energy.
Yeah, good job. Yep, energy type has changed like from motion to sound energy. And thank you, Myth. And I wonder, Katie, can you give us an example, another example of energy transformation? Katie, can you think of another example of energy transformation? What about when we plug in the speakers?
From battery to a lamp.
Good. What kind of transformation is that? From what to what?
From chemical to light energy.
Good. Yeah. So batteries convert. Thank you, Katie. So batteries convert chemical energy into electrical energy. Like it stores the power, it stores the energy as chemical energy. That's why they're full of acid and why you shouldn't lick them. Didn't think I'd have to tell you that during the hands-on activity building circuits, but there we go. And then it transforms it from that electrical energy into the light energy coming out of the lamp. Very good. Now I'm going to turn on the microphones, and I know you're all going to shout, so we'll just shout for 5 seconds, and then I'm going to do what I did yesterday. I'm going to read out a piece of vocabulary, and you're going to read out the definition. Okay? Because I really want to make sure that this sticks in your head. And ready? So, class, what is a collision?
Impact
Impact or crash. Good job. Good job. What is energy transfer?
Energy
Say.
Potential energy.
stored energy.
Motion energy.
Energy transformation.
Energy type is change.
Energy.
Good. To collide.
To collide
To hit, impact, or crash into.
Good. And potential.
what it could be.
It could be or become.
Lovely. Very, very good. Okay. And quiet time. God, I love this button. Okay. So now that we've gone through the vocabulary, we're just going to quickly recap stored energy, potential energy, and who hasn't said anything to me yet? Goku. And then Hurricane. Goku. Hello. Goku, what kind of, or how does the plate have potential energy?
Potential energy.
Mm-hmm. How does the plate have potential energy, or why does the plate have potential energy in the waiter's hand?
Because when the man picked the plate up, I don't know how to say it, but
Yeah, what force is pulling it down? What force makes it want to fall?
it height.
The height, yeah? The height gives it potential energy. But what's the name of the force that pulls things down to Earth?
Gravity.
Yes, gravity. Good job. Okay, thank you, Goku. And Hurricane, can you tell me how a spring has potential energy?
When we push it down, it wants to. I don't know how to say it.
It wants to ping.
Yes.
Yeah. So then, when we release it, all of that energy is as well. Good job. Yeah, when we squish it. And Kangyan.
Yes.
Hello. Kangyan, how does a rubber band have potential energy, stored energy?
They can pull. They can pull out.
Yeah, so when we stretch it, and then when we release the rubber band, what does it do? What does the energy do? What does it transfer into?
Into motion.
Motion energy. Good job. And it goes flying across the room. Lovely. Now, what we're going to do, guys, is Jake did what? You've got 6 different events here. And what we're going to do is going to read through them. And then collectively, we're going to decide which one happened first, which one happened second, third, fourth, fifth, and sixth, okay? And we're going to think about it logically. We're going to think about it critically, like what has to happen first before the other things can happen. So this is a little bit of an introduction into the cause and effect again. Who is chatting to me? Yes, absolutely right. Okay, cool. I'm going to turn on your microphones. I want you guys to read it, going across this way, and then the second line. Okay, so everybody, microphones on, hang on. It's going to sound beautiful, I know. Neymar, Gangster Life, Thug Life. Everybody read this one.
Jake
Go.
and
the pogo stick
Stop. Do you think that's first?
No.
No.
Why?
Because if
I
there
don't know.
are no energy that stores, they will not release and
Nice.
don't jump into the air.
Good, okay. So it needs stored energy first. Read this one.
Jack uses his weight to
Pogo stick.
Good.
Pogo stick.
Donna, where are you? There you are. Okay, class, read this one.
Jack and
The pogo stick of the energy.
Good. Do you think that's first?
No.
No, I don't think so either. Guys, turn your mics on. Okay, number 4 down here.
The pogo stick.
Okay, this one.
Jack and the pogo stick energy before they move up on the ground.
Good. And this one.
The spring in the pogo stick stores energy.
Energy.
Lovely.
Energy.
Okay. Right, so quietly now, I want you guys to have a look at these again, and then I want somebody to tell me which one they think, whoops, microphone, which of these events they think happens first, and then somebody else is going to tell me why. Okay, so have a read. I'll give you a few seconds to read through it again. So Jake and the pogo stick move up into the air. Jake uses his weight to compress the spring in the pogo stick. Jake and the pogo stick use up all of their motion energy. The pogo stick releases its potential energy. Jake and the pogo stick have potential energy before they move back down towards the ground. The spring in the pogo stick stores energy. Okay, now does anybody want to go first, or will I start choosing you at random? Lily.
I think the first one is Jake uses his weight to compress the spring in the pogo stick.
Good job. I agree with you. So I'm going to give that a number 1 there. Thank you, Lily. Right. What do we think happens next? Lisa?
I think the next event is the spring in the pogo stick stores energy.
Good job.
Number 2.
Number 2. Cool. Thank you, Lisa. So So far, we've got Jake's used his weight to compress the spring of the pogo stick, and that spring has now stored energy. What's going to happen next? David,
Yes.
what's going to happen next? So Jake's used his weight to push the pogo stick down, and the spring has compressed and stored energy.
The pogo stick releases potential energy.
Good job. Number 3, thank you, David. Now, as it's releasing its potential energy, what's happening? What's it going to do? Courage. We've got 3 options left. So Jake's used his weight to compress the spring in the pogo stick, which has stored energy, and the pogo stick is releasing its potential energy. And what does a spring do when it releases its energy? Okay, I've lost courage, but Maradona?
Like and the pogo like move up into the air.
Good job. Yeah, so that's number 4. So as the spring releases its energy, it pushes Jake and itself up into the air, turning it from potential energy into motion energy. Good. Okay. Viet Hung, what's next?
Jake and the pogo stick use all up of their motion energy.
Good. 5. So it's gone up into the air and it's used up all of its motion energy. And then what's going to happen last? Ronaldo. What's last? What's the last one that happens?
The pogo stick up potential energy before they move back down toward the ground.
Good job. Okay. And Ronaldo, what's the force acting on the pogo stick to pull it back down? What's the name of the force that pulls everything down to earth?
Gravity.
Gravity. Good job. In fact, I want everybody, microphones. Lovely. Everybody, what's the name of the force that pulls things down to earth? Gravity. Good. What is the force that makes things?
Gravity.
Good job. And what force takes over after an object has used up its motion energy? Okay, good job, guys. Yeah, so I thought that would take a little bit longer than it did. What I'd like you to do, though, is I want you to read out the order of events in the correct order, starting with Jake uses his weight to compress the spring in the pogo stick. So turn your mics back on and keep them on until I turn them all off again, okay? Okay, guys. Jake did what? What was the first thing he did? 1, 2, 3, go. Good. Stop. Number 2.
The spring in the
What is the result of that? What's the effect of that? Number 3.
The pogo stick releases potential energy.
Good. And then? Good. Number 5.
The pogo stick use up all of their motion energy.
Good. And what's the effect of them using up all of their motion energy?
Jake and the pogo stick before they move back down towards the ground.
Good job. Okay. Thank you. Nice quiet time again. Good job, guys. I thought you'd have more trouble with that one than you did, but nicely done. Now I'm going to clear this, narrating what I do. Okay. What do I got next? Aha. Okay. So going deeper into analyzing cause and effect relationships, especially in collisions, I'm going to show you each slide. There's 4 blue slides coming up. Each slide, there are going to be 2 scenarios. We're going to read them and we're going to decide which one has the biggest collision. Then we're going to discuss why. Okay. So, number 1. A truck with a mass of 10,000, that's meant to be kilograms, colliding with another truck with a mass of 10,000 kilograms. That's scenario number 1. Or number 2, a car with a mass of 2,000 kilograms colliding with another car with a mass of 1,000 kilograms. So which of these 2 scenarios, pen, 1 or 2, will have the biggest collision? James, which scenario will cause the biggest collision?
The first.
The first scenario. So scenario means situation. The first scenario. Why?
Because it the objects that collide with each other have a bigger mass than the objects that collide with each other in the scenario.
Good
2.
job. Okay. Excellent. Thank you, James. Ace, you're going to tell us what's the relationship between mass and collision. Remember that the greater the mass,
The greater the mass, the more the collision.
good job, the greater the collision. Thank you, Ace. And what will the effect be? I think you can imagine what the effect will be of them colliding, but I want you to tell me anyway. Katie, what? So James said that if they've got a large mass and they collide, there's going to be a big collision. So what's going to happen to the trucks when they collide? Are they just going to bump like in the bumper cars, or are they going to ka-tish?
It will crash very hard.
Good job. There'll be a lot of damage. That's right. Clear that a second. Thank you, Katie. Oops, sorry. Just stay muted. I want somebody else to tell me about what the motion energy is going to do from one to the other. This is a simple question. Kyan, are you there? Kyan, what is the motion going to do from one truck to the other truck? It's going to, if it's going to move, what's the word for move? Energy what?
Motion energy.
Motion energy is
No,
going
energy
to...
transfer.
Yes, good job. So the motion energy is going to transfer from one truck to the other. And because they've got a large mass, it's going to be a big collision and a big crash. Thank you very much. Oh, hang on. Who's asking the question? Goku. I don't know why the trucks crash. What happened? I don't know. You can decide what happened. Maybe someone was picking his nose and he wasn't concentrating. Maybe someone was eating a sandwich and he dropped it and he wasn't watching the road and they collided. I don't know. Right, number 2. What scenario will cause the biggest collision? A duck traveling at 80 kilometers an hour, colliding into the back of a cow, traveling at 100 kilometers per hour. Or a cow traveling at 80 kilometers per hour, colliding into the front of a duck, traveling at 100 kilometers per hour. Okay, now to help you understand this, I'm going to draw very badly a little duck. Fly duck. Moving this way into the back of a beautiful cow, right? Who's going this way? Cow's going this way. Tail. Or purple. A cow traveling. Oh, I'm such an artist, especially in the computer. Into the front of a duck. There we go. Now, oh, c'est magnifique. Right. What are we talking about in this one? So last time we talked about mass. What do you think we're talking about? There's 2 things that we're talking about in this one. Lily, what 2 factors do you think we're talking about
Can you say again the
Yeah.
question?
So we've got a duck traveling at 80 kilometers an hour, colliding into the back of a cow, traveling at 100 kilometers an hour. That's scenario number one. Scenario number two is a head-on collision. The cow is traveling at 80 kilometers an hour, and it hits the front of a duck that's traveling at 100 kilometers an hour. These are very fast animals. Do you think we're talking about mass?
No.
No. Do you think?
Speed.
Yeah, we're talking about speed. So we know from here, and here, and here, and here that we're talking about speed. We're talking about something else as well. And it's to do with this. So speed is important, and so is, remember when we're bowling, if we throw the bowling ball in any direction, it might not necessarily hit the pins. So we've got to be careful about which direction we throw it into. So what do you think the other factor is? Aisha, we're talking about speed as one factor. And then why does it matter if they hit into the back of each other or if they hit into each other head on? Maybe Ace, can you tell us?
Head on.
Yeah, head on is going to be worse because what else is important when we're talking about collisions?
The speed and
Right.
and the sizes of the collision.
And the what?
The
I'm slowly
speed
writing
and
it. I'm trying to give you the size. It's not the size in this one. Talking about, go on, say it before I write the whole word.
Where
And the what?
Where does it hit?
Yeah, exactly, where it hits. So that's the direction. Job. So in this scenario, or in these scenarios, the speed is important and so is the direction. Now, technically, the speeds are the same. We're going to have a total speed. If we just had them, if they were facing in the same direction, they would have the same total speed. But which one's going to have the biggest collision? Veg to blue.
Yes.
Which of these two scenarios is going to have the biggest collision? Number one, where it's bump into the back of them, or number two, where it's head on?
I think the number one.
You think number one? If the duck goes into the back of the cow is just going to move forward faster. What's going to happen if the duck and the cow hit each other head on?
They will crash each other.
Good. Do you think they'll keep moving or will they stop?
Stop.
They'll stop. Good job. So which one do you think has got the biggest collision?
Two.
Number two. Nice. Okay. Thank you, Vegetable Blue. Why? What will the effect be? We just talked about that. I think I've got some pictures now. Which scenario will cause the biggest collision? Ah, yes. Okay. Big drummer dude. Whoops. Dead drummer dude. Or My Little Pony drummer dude. Now, I want you to think about collisions from when we did our musical instrument experiment. You guys know the faster that you hit something, the bigger the collision. So the faster that you swing the drumstick, the louder it gets. But also, so the more force. I want you guys in a moment to circle the drummer that you think can make the loudest sound, or the drummer that can make the biggest collision. And then I'm going to ask you guys why after. So I'm going to turn on annotations. I want you to use a nice color, something that goes nice with blue, maybe purple or yellow or green or something. And I want you to circle the drummer that you think will make the biggest collision, and then tell me why. Queen Dan has voted. Maradona's voted. Viet Hung, circle. Thank you. Nobody's got no love for Pinkie Pie. Okay. Yeah. So I guess that and stop. It was mostly unanimous. But I tell you what, I want to ask Maradona why he picked the zombie guy, the skeleton. Maradona, what did you choose?
The skeleton guy.
Why?
Because I think when he hit the drum is very close together and will make a loud sound.
So it's because the drums are closer together. That's an interesting point. Okay, so if it's a larger object, cool. All right, thank you. What about Ronaldo? What did you choose?
I choose a man
Why did you choose the man?
because I see he was big and I think he is strong.
You think he's strong? Good. Okay, so if he's big and strong, how will that affect the collision on the drums? Will he be
He
able to
will
hit?
hit very very strong and the drum will make very loud sound.
Good. Okay, so will that be the speed or mass or both or what?
I think the speed.
Yeah, he'll have more speed and mass. Okay. Why didn't anybody pick Pinkie Pie? Hang on. Where's my vote? Pinkie Pie, My Little Pony. There's no place like Ponyland. Right. I want to ask. Hello, Goku.
Hello.
Why didn't you choose My Little Pony? Why not?
I don't know how to say it.
Try me. Do you think she's the strongest?
No.
Do you think she's the weakest? Okay. Do you think she's the fastest?
Yes.
Ladies and gentlemen. Oh, okay. Well, if you think she's the fastest, then maybe she'd have a big collision since they're connected. Maybe Queen Dan.
Yeah.
Why have you got no love for My Little Pony? No love for My Little Pony. Why do you think she's not going to have the biggest collision?
Because she's too weak and quite fast, but I don't think that she's more fast than the guy.
Good. Okay. Yeah, that's it. That's a good answer. All right. Thank you very much. We've got one more. Clear. That. Right. Which scenario will cause the biggest collision? So you're going to have a look at one of my favorite things. Can I put this down here? Will you be able to see? Is it going to be Little Pikachu using Body Slam? Or is it going to be Buff Pikachu using Body Slam? Now, I wonder, can anybody tell me what the move Body Slam does? Can anybody use raise hand if you know what Body Slam or what you think it might mean? These are attacks in Pokemon. Who's got their hand up? Let's have a little look-see. Viet Hung. You ready? Viet Hung, what's Body Slam? What does Body Slam mean? What two words has it got?
Body slam.
Body and slam. So what do you think the attack does?
The body slam into someone's face.
Yeah, it's like a belly flop. You know when you jump into the water, like jump into the swimming pool, just belly first, just like wham. Okay. So Viet Hung, are we talking about speed or mass or direction or what are we talking about here? Do you think?
Talk about size.
Talking about size. Good. Size. And where is he?
What
There we
the?
go. Yes. So this is what I do when I'm looking for your lessons. When I'm making your lessons.
Oh, no.
Yeah, that's buff Pikachu. Little Pikachu, buff Pikachu. Right, guys.
The buff Pikachu will lose because it is nonsense.
What? Why?
Because the buff Pikachu is nonsense.
Explain.
Because it's not real. Even
Oh,
Pikachu.
okay. All right. Well, let's just say for this instance that he is. Let's just say that all Pokemon are real. They are all equally real. I want you guys to circle the. Actually, no, I don't want you to circle. What I want you to do is I want you to cross out the Pikachu that you think is going to get squished. Okay, the one that's going to suffer from the biggest collision. Okay, which Pikachu is going to die? Annotations on. 3, 2, 1. So cross out the Pikachu that's going to die. Good. And stop, because now it doesn't make any sense. Apparently they all died. Yes. Why? That's not right. Why on earth would that happen? Oh no, my Pikachus! My Pikachus! No, I can't see it. There we go. I love this picture. I'm really glad I found it. Okay. Viet Hung, I love the sound of your voice, but you're going on mute, buddy. Right, there we go. I want somebody to tell me what they chose and why. Who hasn't spoken to me very much, apart from Alex? How about Myth? Hello, Myth.
What?
What? Myth, which Pikachu would die?
The Pikachu level 1.
The little Pikachu. Why?
Because he not strong enough. Strong like the Puff Pikachu.
The buff Pikachu is stronger. Good. Okay. Do you think their mass has anything to do with it? Which Pikachu do you think has more mass, or which Pikachu do you think is heavier? Myth. Which Pikachu is heavier?
Puff Pikachu.
Buff Pikachu. Yeah, buff Pikachu is heavier. So buff Pikachu is going to have more mass. Thank you. And Courage. Hello, Courage.
Yes.
If buff Pikachu has more mass, then which collision will be greatest? Which collision will be bigger? A little Pikachu body slam or a buff Pikachu body slam? Which one will have a greater collision?
The buff body Pikachu.
Good. Can you tell me why? I just talked about it with Myth. Because the greater the mass, tell you what, microphone's on, everybody. The greater the mass, 1, 2, 3.
The greater the collision.
Good. Tell me about speed. The greater the speed.
The greater the speed, the greater the collision will be.
Good. Two
And
more.
the Pikachu,
Everybody.
small Pikachu was faster.
He might be faster. If they use quick attack.
He used his head to hit the buff Pikachu.
Good. Do you think little
Hit
Pikachu
the
could have won?
belly.
If little Pikachu used quick
Everywhere.
attack, would he win?
Yeah.
Why?
Also, the little Pikachu can use the Iron Tail because the buff Pikachu was bigger and he can't jump.
So buff Pikachu has a lower speed. I believe that. Okay. I'm glad you know that because that's actually coming up in your quiz tomorrow, in your online quiz tomorrow. I've got just a couple of I think it's only two. I think I've got two Pokemon questions in your quiz that are to do with moves, like quick attack, which is obviously to do with speed. And the greater the speed or the higher the speed, the greater the collision. So if you've got a Pikachu that's going really, 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 really fast and it hits you, that's going to hurt a lot more than a lazy Pikachu that isn't moving very quickly. Now, oh, there you go. I've done one here. I forgot I did this. Okay. What moves could Heavy Snorlax and Quick Speed Jolteon use against each other? I forgot that I put this slide in here. I thought we had something else coming up, but this is fine. I want you to think about it a second. Okay. What moves could Heavy Snorlax and Quick Speed Jolteon use against each other? Which moves would be most effective? And why? Harry Kane, what do you think? So, Harry Kane, we've got a big, heavy, slow Snorlax, and we've got a small, quick Jolteon. What moves do you think they could use?
I think Snorlax would use body slam
Yeah, good. Why would that be effective?
because he's heavy.
Yeah, because he's heavy. He's really heavy. Good. Thank you, Harry Kane. Lisa, what do you think? What moves do you think they could use? So Snorlax is really heavy. He should use something like Body Slam.
I think I did not play Pokemon, so I don't know.
That's okay. That's why I've kind of put these answers in here. If Jolteon is very fast, do you think he should use a Body Slam move, or do you think he should use a quick attack?
A quick attack.
Good, because why? What's speed got to do with collisions?
The bigger the speed, the bigger the collision.
Yes, good job. So this little Jolteon will have a much better chance at causing a big collision if he moves very, very quickly. Thank you, Lisa. Who else got the hand up? Ace, what do you want to say? What do you think?
I think that the Snorlax could use body slam and the Jolteon can use fast attack
Good. Why?
because the heavier the heavier the thing is, the smaller the collision is, and the faster the thing is, and the more the collision is too.
Good job, Ace. Exactly. Lastly, I just want to ask you guys, what would happen if they swapped moves? What if the big, heavy Snorlax tried to use a fast attack or a quick attack, and the little Jolteon tries to use its mass if he tried to use a Body Slam? Now, raise your hand if you want to answer. Use the raise hand function. Okay, Katie. And then I'll ask if you get hung before he explodes.
Maybe the Jolteon will die.
The Jolteon would die. Why?
Because if without the quick speed power, Snorlax is still very heavy, and the Jolteon body is too small that Snorlax can smash it.
Ah, good job. So even if it's got a low speed, he's still got a very big mass. He's still got a very big body. Good job. All right. Queen Dan, what do you think?
Well, I think Snorlax is fine if Jolteon use quick speed and made a collision, but his belly is so fat that it could be his weapon to win.
Yeah.
Yeah.
It could absorb the impact. He might be like a crash mat on a trampoline. Good. Okay. Yep. His mass is so big. David, what do you want to say?
Yeah, I think the Jotun, if the Jotun used the quick attack, she might be bounced back, because if she hit the Snorlax's belly,
She'd bounce off. Good, yeah, maybe. Alrighty, guys. I've just seen it. We're out of time now for today. But tomorrow I'm going to give you a quiz on collisions. So I saw that some of you took some notes, and I'm really pleased to see that, or at least you were able to read notes. I was asking you things, particularly to do with your vocabulary that you've been learning. Right, so tomorrow you've got a quiz, so have a look over stuff to do with collisions. It's going to be a live speed quiz, so you won't have too much time to click around and find things. But for now, I would like everybody to say goodbye to each other, so I'm going to turn your microphones on.
Bye bye. Bye bye.
Bye.
Bye bye bye.
Bye bye.
Bye bye bye.
Next time,
Thanks very much.